Hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem: container with most water. Okay, so what the problem is saying is we will be given an array, okay, of non-negative integers where each element represents the height of vertical lines. Okay, so you can consider, for example, this is a graphical representation of the array. Okay, so here are the vertical lines. For example, at the zeroth position, the vertical line is of size is of height 2, right? Which is the first element. The second element is 1. So here the height of the vertical line is 1, okay, and so on. Okay, so what we want to do is we want to find out the maximum amount of water, which can be stored between any two given lines, yeah. So for example here, right, uh, between these two lines, how much water can be stored? So this is the level. Or or for example or for example between these two lines, right, between these two lines, how much water can be stored? The water can be stored is this much, right, this much, right, this much. Okay, okay, so we have to calculate, or we have to find out the maximum amount of water which can be stored between any two given lines. Okay, now in this particular example, which what is the maximum amount of water which can be stored? Okay, the maximum amount of water which can be stored is between these two lines, 2 and 7, between these two lines. How? So if you see here, right, so the maximum amount which can be stored, okay, and it can be stored across the lines, right, across the lines in between. Okay, so it will be this much level. Okay, and why this much level? Because the minimum, we have to find out the minimum out of the two lines, and which what is the minimum out of, for example, the height of this particular line is 5, right? You see, if you see, and the height of this particular line is 8, 8, right, 8. Okay, and which is the minimum out of this two? The minimum is 5. Okay, so hence the maximum, right? If why the water cannot be stored? Because of obvious reasons. No need to explain. The water will overflow, right? The water will overflow, and that is why the amount the water can be stored will be at this level. Okay, now how to calculate how much water will be stored? So we just want to calculate the area, basically, of this space, of this space, area of this space, and that will give us the answer. So what is the area? How we can calculate? So first of all, you have to calculate this the the width, we can say, right? The width. What is the width? 7 minus 2 will give us 5, right? 7 minus 2 will give us 5. And the height, right? We got the width, now we want the height. And what will be the height? Height will be the minimum between the two lines. What is that? 5 between what is the minimum between 5 and 8? It is 8. So we have our height, right? We have our height, which is 5, and we have our width as well, which is this, right? Which is this, which will give us answer what? 25. So 25 is the right answer. So the water can be stored in this particular area, and this is maximum area. Okay, this is a maximum area. So I hope you got the problem. Now, how can we solve this problem? So once you got, it will be, I think I'll make it very easy for you. Okay, so first of all, let's quickly see the naive approach. Okay, the naive approach. What will be the naive approach? Let me write it here. We'll have two for loops, I equal to 0 to n, right? And another for loop will be j equal to I plus 1 to n. Okay, and what we are going to do is we're going to calculate the area, right? The area, the rectangle area, we can say, right? And what will be that? What will be that? See, j will always be greater than I. That is for sure. So if I want to calculate the width, it will be j minus I, right? That's what we did. 7 minus 2, j minus I. This is, for example, this is j, this is I, j minus I, into whatever is the min between air of I and air of j. That's it. This will give you the area. Okay, this will give you the area. Okay, now we'll have a max area. Okay, max area will have a variable which will initialize with int min, and we will, at each, right, for each j, we are going to check max area equal to max area and area, right? So this pseudo code will give you your answer. Okay, but what will be the time complexity? The time complexity is going to be O of n square. Okay, so this is a naive. We need to find some better approach. Okay, so let's quickly see what can be the better approach. Let me erase this first. Okay, so let me do one thing. Let me rewrite this. Okay, let me erase this. Okay, now let's see the better approach. So what we're going to do is, let me rewrite the array again 2, 1, 8, 6, 4, 6, 5, and 5. So what we are going to do is we are going to solve this problem using two pointer approach. So what we're going to do, we are going to have one L pointer and one R pointer. Okay. Okay. And what we are going to do, so we are going to have one water stored variable and one max water stored variable. Let me write max water stored variable here. Max water stored. Okay. Here we'll initialize with int minimum. Okay. Int minimum. Now we are going to check L and R, right? L and R. So whatever, so we are going to check the area, right? What is the area here? Area will be R minus L. R minus L. What will be the formula? R minus L into min of A of L and A of R, right? So for this, what will be the area? R minus L will give you what? R is 7, L is 0. So area will give us 7 minus 0, okay, into minimum of 2 and 5, right? 2 and 5, the elements, the height of the vertical lines. Okay, so what will give us? 7 into minimum 2, which will give us 14. We're going to check this area contains 14. We're going to check with max water stored. It is anyways minus infinite, right? Which is in minimum. So we'll update our answer with 14. Okay, and then again we'll check whether this lower L pointer, if it is less than the element at the L pointer is less than element at R pointer, then we're going to increment our L. Yes, it is less than, so we're going to increment L. Again, we're going to check here. So according to the formula, R will be as is here. So according to the formula, 7 minus 1, okay, that is R minus L into min of 5 comma 1, okay, which will give us what? 6 into 1, which will give us 6. So we compare with max stored. Okay, max stored is bigger, so we won't touch that. Okay, again we're going to check here. Is L less than R? Yes, it is. We're going to increment our L. Okay, now L will point here. Okay, now what are we going to do? According to the formula again, R minus L. What is R? What is R? 7. 7 minus L. L is what? 2. Into min of the elements at LNR, right? 8 and 5. So will give us what? Min will give us 5 into 5, which will give us 25. We're going to compare this 25 with this max water stored. It is lesser. We'll update this 25. Okay. And now we're going to check here. Is 8 less than 5? No, it is. No, it is not. It is not. So we're going to update R or decrement our R now. Okay. Again, we'll calculate the same formula, right? Okay, the same again, this particular formula, right? Area, and we'll compare with what max water stored. And now again, if you're going to check, is 8 less than R? Is 8 less than 5? No, it is not. So we are going to decrement our R, and so on. We will proceed till L should be less than R. Once we reach L equal to R, we're going to break out of the while loop. Okay, so this is the intuition behind solving the problem. I hope you have got the intuition. Just one request to please subscribe to the channel, as I've tried to make it very easy for you, very descriptive for you. Okay, so let's quickly see the the Java code followed by C++. Not much difference between the two codes. Add dot length. Then we'll also discuss the time complexity. Low equal to 0, int high equal to n minus 1, right? We'll run a while loop. L low less than high. Okay, now we're going to have max stored. Let me make it short. Max stored equal to integer dot main underscore value, right? Underscore value. Now we're going to store water stored. Let's say water stored equal to high minus low into math dot min air of high air of low, right? And we're going to compare max stored. We are going to store if water stored is bigger than max stored. Okay, we are going to store. Okay, so let me have math.max water stored comma max stored. Okay, and we are going to check here if air of low is less than air of high, then we are going to increment our low. Else we're going to decrement our high. Okay, that's it. And finally, we're going to return max stored. We're going to compare if integer dot min value. That is, we cannot store the water at all. Then in that case, we have to return 0. Okay. Else, if there's some water stored, then we return the max stored. Okay. This is it. So we'll discuss the time complexity as well. It's very simple. So, oh, some issue. What is wrong? Okay, here it is. Sign. Let's compile again. Uh, what is the issue here? Return max stored. Int cannot be converted to boolean. Oh, here it should be equally. Okay. I hope no more errors now. Okay, let's submit this. Okay, thanks for watching. Please don't forget to subscribe to the channel, like the video. Let's quickly see what is the time complexity here. The time complexity will be off n because we are treating to the array only once, and space complexity will be off 1 because we are not using any extra space. Thanks for watching. Please subscribe to the channel, like the video. Let's quickly see the C++ code as well. So it's a C++ code, not much difference here. We have taken array of size here, and max stored will be int underscore min. Rest like all the minute differences, right, in the standard library functions of min and max. Okay, so thanks for watching. Please subscribe to the channel, like the video. I'll attach the code in the description section. Thanks for watching. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.